Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So, sit back, grab a notebook, and let's dive into today's problem. Alright, today's problem is from a request from a viewer, Toki3256. He said, "Hi, I need help to solve this problem, please. A crystallizer contains 6,420 pounds of aqueous solution of anhydrous sodium sulfate, concentration 29.6 weight percent at 104 degrees Celsius. The solution is cooled to 20 degrees Celsius to crystallize out the desired sodium sulfate dot 10 H2O. The remaining solution, the mother liquor, is found to contain 16.1% anhydrous sodium sulfate. What is the weight of this mother liquor?" It's slightly oddly worded. But I think what it means, because it kind of threw me off when it said it was an aqueous solution of anhydrous sodium. Anhydrous means no water, so it's and aqueous means water. So it's like there's this water solution that has a salt in it that doesn't have water in it. It kind of like threw me off a little bit. But what I think they mean, what I'm taking this to mean is that if you removed all the water, this is how much anhydrous sodium sulfate would be in the liquid. Okay, so it's basically just telling us the weight percent or the concentration of the salt in the aqueous solution. That's how I'm taking that. If I'm wrong, just send me another comment and maybe I can clear some things out, but I think that's what they mean by that. So then they cool down the solution and then some of the salt comes out, but the salt doesn't come out as anhydrous sodium sulfate, right? Because it's surrounded by water, so it'll be just kind of like this other salt crystal. A lot of times I've seen these salt crystals kind of be like almost sludge-like when they come out of solution. They're still solid, but they've got a lot of water content like trapped within the crystal. So in this case, they've got a ratio of 10 to 1. So for every molecule of salt, you have 10 molecules of water that is attached physically to the salt structure. So even if you strained that out and removed all of the liquid salt and dissolved salt, the liquid water and dissolved whatever, the mother liquor is what they call it. If you remove all that, you would be left with a solid that is 1 part sodium sulfate and 10 parts water that's trapped within the crystal. Okay, hopefully that makes sense. Hey all, in editing, I decided to make a quick aside about some additional information related to this problem. As I've looked into this issue, I noticed that many people have already shared the solution online. To complement the existing explanations and make it easier to understand, I've created a video explanation for you. Moreover, there's another problem similar to the one at hand, which involves crystallizers and hydrated compounds. If you're interested in delving deeper into this topic, I've made another video in episode 065 that relates to this. You can find the link in the top right corner of this video. Happy learning. The remaining solution, the mother liquor, is found to contain 16.1% anhydrous sodium sulfate. What is the weight of the mother liquor? Okay, the other thing that I don't like is that they say what is the weight, because when I weigh something, it makes me think of a force. So I didn't like that. But what I think they mean by weight is they're talking about the mass, and because they're writing all of these things in pounds, and pounds can either be a measurement of mass or force. I'm just going to go with that. I think that they're talking about pounds mass instead of actual weight. Okay, so moving on from there. Oh, by the way, thanks Toki. I don't want to like be picking apart your problem here. Thank you for submitting a problem. I do enjoy doing viewer submitted problems a lot, so thank you. Sorry if I came off as snooty. I'm just kind of picking this apart, trying to understand it. That's where I'm coming from. So big shout out to Toki3256. Thank you for submitting a problem. All right. Okay, so let's move on. We've got our problem statement basically written out here. Got an aqueous solution. It has a total mass here, and then they gave us how much sodium sulfate was in it, and then you just say 1 minus that is how much water is in it, because we're assuming we don't have any solids yet. Okay. Then we go from T1 to T2, and the stuff crystallizes. We still have the same mass, like we haven't lost any mass, we've just changed temperature, right? So the same mass going in that we got going out, okay? But then they told us that we've got a certain amount of sodium sulfate here. It has changed, and now we have a new product. I just abbreviated that, sodium sulfate 10 water as Na10. I think I wrote it out for the rest of the problem later on, but yeah, this just kind of helps you see that we've got a couple unknowns here, got a few species, we've got this equation going on. You have sodium sulfate plus 10 water goes to sodium sulfate dot 10 water, okay, as a solid. Okay, we will need to work in moles because we have a chemical reaction going on, so we need to convert all of these masses into moles, and in order to do that we need the molar masses. Okay, so I calculated the molar masses for all of these things. You could probably also just Google them. Sometimes it's just faster to calculate it, because Google can sometimes not know exactly what you're talking about if you don't use the standard notation. So now we've got to convert everything to a moles basis. So I took our information about stream 1 here, and I'm going to convert it into a moles basis now. So I need to know how many moles of sodium sulfate there are in stream 1. The way that I do that is this numerator represents the mass of sodium sulfate in stream 1, and then I divide that by the molar mass, and then I get this in pounds mass, or pounds moles. Okay. Then I do the same thing here for the water in stream 1, and I get that there are this many moles of water in stream 1. Okay, and in order to calculate the total number of moles in stream 1, I just add those two things together because there's only two components, and then from there I can calculate the the mole fractions in stream 1. Okay. Then I do the same thing for stream 2 for the information we were given, and I say how many moles of sodium sulfate are in stream 2. That's what this is. I say, okay, there's this much mass of sodium sulfate in stream 2, and there's this many, this is the molar mass of sodium sulfate, so then that means there are this many moles of sodium sulfate in stream 2. Okay. Well, now we have enough to do a sodium sulfate balance, right? Okay, so let's do the sodium sulfate balance in moles. We say we have this much sodium sulfate going in, and we have how much going out. We have a certain amount going out in stream 2 still as sodium sulfate, but some of the sodium sulfate also went over to make sodium sulfate 10 water. Okay. So that much was consumed as well. So we lost some because it left, and we lost some because it was consumed. So we add those things up. We can solve for how many moles of sodium sulfate in the water crystal form. Okay. Or sorry, in the crystallized form. So we've got our crystallized moles here, and it equals this much, because we know these two quantities. Okay. Then we go back into mass, because the whole point is to know what is the weight of the mother liquor, right? So we need to know how much mass this equals. How much mass did we lose to the crystallization process? Well, we now have the number of moles, so we can just use the molar mass in order to figure out how much mass that is. So moles to mass, we just use the molar mass, and we get that this many moles equals this much mass, okay? And then we say, okay, well, if we have this much mass of the crystal and we remove that from stream 2, how much aqueous solution do we have left of sodium sulfate and water? And that's what I represent with L here. I say we know what the mass of stream 2 is, and we know how much mass was crystallized. So we just solve for the mass of the remaining liquid with the salt in it, and that is the mother liquor, and the mother liquor has 4,242 pounds left. Okay, so that is the mass of the mother liquor, and that's what the question asked for. So we are done with this problem now. Okay, so that is it for this problem. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you could take to arrive at the same correct answer, and I encourage you to leave a comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, like the one that I did for Toki here, or Toki, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem-solving videos. Thanks again, and I'll see you in the next video.